At time t minutes, the rate of change of temperature T degrees centigrade of a body as it cools is proportional to the temperature of the body at the time. The initial temperature of the body was 80 degrees centigrade. So first we need to show that T equals 80 times e to the power minus kt, where k is a positive constant. Then given also that T is 60 when T is 5. So that's the temperature and the time. Find the time taken for the temperature to fall to 40 degrees. So this T has to come to 40 degrees. Okay, so find the value of the temperature when the time is 10. So what we do is we form the differential equation first. So it says that at time t minutes, the rate of change of the temperature T. So rate of change of the temperature T can be written as dt over time, temperature over time, and that is equal to, so it is proportional to the temperature of the body at the time. So this would be proportional to, so that means there would be a constant, and the constant would be negative. So I would put in as negative k, and proportional to the temperature of the body. So minus k and the rate of change, that would be t. Okay, because it's proportional here. So that's what is the start. So then what I can do is I can write this as dt over t is equal to minus k dt, and then I can integrate both sides. So I can say integrating, so that would be integrating 1 over t dt is equal to integrating minus k dt. So this would give me log to the base c, t is equal to minus k t plus c. So that is what we get as a first step. So from here we need to get to this bit. So for this we will use that the initial temperature of the body was 80 degrees. So initial temperature of the body was 80 degrees. What it means is, if I say I'm working on part A, so then at time t equals 0, the temperature is 80 degrees. So I can write log of 80 is equal to minus k times 0 plus c. So c is equal to ln or log 80, and then I can do substitute so I can write and that would mean ln t over 80 is equal to minus kt, and then raising it to the power of e. So t over 80 is equal to e to the power minus kt. Therefore, t is equal to 80 times e to the power minus kt. So that is part A. That's what we've been asked. So that's done. The next bit is saying, given also that T is 60 when T is 5, find the time taken for the temperature to fall to 40 degrees. So for this bit, so for B, telling me T is 60, time is 5 minutes. Then using this I can actually find k. So I can write 60 is equal to 80 times e to the power minus k times 5, or 60 over 80 is equal to e to the power minus 5k. So I can say bring back in log 60 over 80 is equal to minus 5k. Then all I have to do is find this, log of 60 over 80. And that gives me minus 287. So then I need to divide it by minus 5. So if I divide it by minus 5, I get 0. So the minus signs cancel out because log 60 over 80 would gives a negative value. So that is k is equal to 0.0575 and so on. So if I write it as 0.058, I might approximate it. So that is the value of k. So hence we can write, what we need to find is the time taken for the temperature to fall to 40 degrees. So then I can write therefore T is equal to 80 times e to the power minus 0.058 T. So now I have to find the time for the temperature to fall to 40. So when T is 40, what we can do is 40 is equal to again 80 times e to the power minus 0.058 T. Once again I can do 40 over 80, and I can use the log is equal to minus 0.058 T. So therefore T will be log of 40 over 80, and that divided by minus 0.058. So we get 11.95 and so on. So that is approximately estimating T is 12 minutes. So that is the answer to the part B. So that's done. Then we move on to the C part. So find the value of the temperature when time is 10. So once again, T is 10. So therefore we can write this as capital T is equal to 80 times e to the power minus kt. We know what that is, 0.058 T. So that is 10. So to multiply it with 10. So then that is equal to 80 times e to the power minus 0.58. So if we take the logarithm, so we can write ln t over 80 is log is equal to 0.58. Oh no, what am I doing? T is something I need to find. So this is what I need to work out. So that is 80 times 80 multiplied by e. So that 80 multiplied by e to the power So that's minus 0.58. And the answer is 44.79. So that is approximately 40, sorry, 45 degrees centigrade. So that is the answer to the part C, and I think that completes this question.